If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture where we are solving previous year JEE Main questions on permutation combination. So in this lecture we will be solving from question number 1 to question number 5. Okay, then let's try to solve these 5 questions. Okay, in question number 1 it is asked, in an election a voter may vote for any number of candidates not greater than the number to be elected. Okay, so you have to see how much voter to be elected, it can vote up to that much. There are 10 candidates and 4 to be elected, so a voter can vote up to 4 votes, 1 2 3 4, because 4 voter can be elected, so it can vote 4 votes. One voter can votes. So if a voter votes for at least one candidate, so if every voter will be voting for at least one candidate, then the number of ways it can be vote. So at least one means it can select 1, it can select 2, it can select 3, and it can select 4 also, because highest is 4, so you cannot go beyond 4. So it is 10C1, out of 10 it can select 1, it can select 2, it can select 3, or it can select 4. So if you solve this one, I think C calculation you can do it. It will be 10 plus 45 plus 120, then 210. So final answer will be 385. So that is your answer, option B. Now if you come to question number 2, what is asked here? Now set S this has to be partitioned into 3 sets A, B, C of equal. There are 12 numbers. If it has to be partitioned in equal size, means each one will having 4. And you will give name to each set, that is A, B, C. So actually you are dividing this 12 into 3 equal groups of 4, 4, 4. So you can see this formula. The groups are divided equally, but in equal you have to see whether it will be divided, whether identity is lost of group or not lost. If it is lost, then divided by that factorial will come. If it is not lost, then that factorial will not come. So you can see, because you are giving name to A, B, C, one set you will write at A, one will write it B, one you will write it C. And it is also given sum of them should be equal to 12, no intersection, no common. So each one will having 4, 4, 4 only, because there should not be any common term. And because you are naming them, so each one has having individual names. So identity is not lost. So that divide will not come. So it will be 12 factorial divided by 4 factorial whole cube. 4 factorial into 4 factorial into 4 factorial. That is your option C. How many different words can be formed by jumbling the letters of the word Mississippi, in which no two S should be adjacent? In Mississippi, you have 4 I's, S is also 4, P 2 times, and 1, M1. Okay, so no two, they are asking you no two S are adjacent. So what you do in this case, no two people are adjacent, so you forget about S, because S is problematic, they don't want to sit together. So you make sit the other people who are not problematic. So you make sit I, P and S. Suppose you put it in this way, 4I, 1 2 3 4, and 2P, and then 1M. So how many ways they can be sit? 1 2 3 4 5 6 7, 7 factorial. But there are 4 repetitions, so divide by 4 factorial. So or these you can do later also, divide by 2 factorial. In between them you put S. So how many in between them there are? 1 2 3 4 5 6 7 8. There are 8 such places, 4 plus 4. In this 8 place you put this 4. Now you can put it 8P4. So you have to choose 4 place and then you have to arrange them also. But there are again 4 I's are similar, so you divided by 4 factorial. So ultimately it will become 8C4, 8P4 divided by 4 factorial 8C4, because you have to see the options and you have to go by that way, because it is all written in C format. And if you write it, it is 7 into 6 factorial by, it will be 7 into this is 8C4, and this is looking like 6C4. So that is your option A. Next, in question number 4, in a shop there are 5 type of ice creams available. A child buys 6 ice cream. The number of different ways the child can buy the ice cream is 10C5. The number of different ways the child can buy 6 ice cream is equal to the number of different ways of arranging 6 A's and 4 B's in a row. So let me check statement C, 1 or 2 both, one by one. So if we start with statement 1, so how to choose this type of questions? This is, you can see there are same type of ice creams available, same 5 different types. Suppose type A. So type A, there are infinite numbers of ice cream. A student, the child can take any number out of up to 6 it can take. So there are different types of items, but each one is repeating some. So you can think it this way, there are n number of things, you don't know which one. Suppose this is type A, type B, type C. So third kind, infinite numbers are there in the market, but he want to take only 6 out of it. So you have to find the coefficient up on x to the power 6. So it can be of this fashion that from type 1 it can select none, it can select 1, it can select 2, it can select 3, it can select 4, it can select 5, it can select 6. I am going beyond that because let me write up to 6 only. So similarly you will write for all 5 items, 5 different types, 1 type, 2nd type, 3rd, 4th, 5th. So you will find the coefficient of x to the power 6 in the product. So because you need x to the power 6 only, so you can add the higher coefficient because that will not create any problem. In the proof also I have explained here. You can add these higher orders because you are taking only coefficient of x square. If you want to find the coefficient of x to the power 6 from here, if you add x to the power 7, it will not make any sense because I am not finding that coefficient. So it is nothing but 1 minus x to the power minus 1. Similarly 5s will be there. 1 minus x to the power minus 1, 5 items. So 1 minus x to the power, it will be minus 5. If you find the coefficient of x to the power 6 from here, what will be the formula? I have explained this one. N plus r minus 1 into CR. So that is your 5 plus 6 minus 1 C6. That is 10C6, which is you can write 10C4. So obviously statement 1 is wrong. So if statement 1 is false, then it is obviously option D. There is no need to check any other thing. Now you can check for your say completeness. Number 2 also is equal to the number of arranging 6 A's and 4 B's in a row. So if you want to arrange 6 A and 4 B, so total there will be 10 factorial and all A are repeating. So 6 divided by 6 factorial and 4 B's, these are also repeating. So divided by 4 factorial. So it will be 10C4 or 10C6, you can write anything. So 2 is true, but 1 is wrong. Next, if you come to question number 5, S1 is given some summation S2 and S3. Okay. So if I start one by one, suppose S1 is given to me, that is summation j equal to 1 to 10. So you can write it in this way. It is 10 factorial, j factorial, and it is 10 minus j factorial. First let me write 10 minus j factorial, and there will be one j factorial. J factorial, what I do, I write j minus 1, j minus 2 factorial, because I can stop, because j factorial is nothing but from j you will go 1. So I am going up to j minus 2, then from j minus 2 to 1 I am giving a factorial size. Because why I am doing so? Because that will make it, I can cancel this one. So you can now think it of this way. Suppose 8 factorial by 8 minus j minus 2 factorial, and it is j minus 2 factorial. Then if it is 8 factorial, then what you are left? 10 and 9, j equal to 1 to 10. So you can write it 90 into j equal to 1 to 10, 8c j minus 2. So what you are doing actually, now because you are starting from j minus 2, so it will not be a j equal to 1, because if you put j equal to 1, that will be minus 1 now. So you need to start from j equal to 2 now, because j equal to 0, 1 you have already cancelled it out, so it will not be. So you can start with j equal to 2 now, because you don't have other options. Negative number factorial does not exist. So if you put j equal to 2, it will start from 8c0, 8c0. Then if you put 1, it will be 8c1, 3. Similarly, it will continue. Last, if you put 2, 10, it will come 8c8. So you know this one. From c0 to cn, if it goes, then it is 2 to the power n. So 2 to the power 8. So 90 into 2 to the power 8 is the first one, S1. So till now, statement 2, this portion is looking good. Let me see now next. S2. This j factorial I am writing j minus 1 factorial. So j get cancelled. So what you can write, you can take 10 out now from here. Now from here you can start from j equal to 2 to 1 to 10 only. And you can write it 9 factorial and 9 j minus 1 factorial. And then j minus 1 factorial. So you can write it 9c j minus 1. You can start from j equal to 1, because 1 it is 0. So it will be nc0 plus nc1, then last if you put it is 9c dot 9c 9. So it will be 10 into 2 to the power 9. So that is your S2. That means statement 2 is wrong. It is given 10 into 2 to the power. It is coming 10 into 2 to the power 9. So obviously it will be, because all the options are same. These standard 4 options, same as 4. So it will be same, because statement 2 is wrong. So it will be obviously option C. For your sakeness, completeness, you can see now. J square, what you can write? J square minus 1 plus 1. Or you can write it like this also. No, if you write it this way, then you will get this and this format. If you add this plus this, then it is j square minus j plus j, it is j square only. So that's why I am using this. So it is nothing but 1 will be this into this, 1 will be this into this. So this into this is S1, this is nothing but S1, and if you do this into this, that is S2. So S3 is nothing but S1 plus S2. So 90 into 2 to the power 8 plus 10 into 2 to the power 9. So you can take 2 to the power 8 common, then it will be 90 plus 1 to 20, 110 into 2 to the power 8. From 110, if you take 2 common, it is 55 into 2 to the power 9. So that means statement 1 is correct. So that's why it was option C. If you like the video, then press the like button and please give your valuable comments in the comment section.